Example of an alternating series test. We call alternating series as if the sum is plus minus or minus plus minus plus. So one example you can use, and again we have seen things similar to this before, -1 to the n minus 1 over n squared. If I write out the term by term, it's 1 minus 2 squared, or 1 minus 1/4, plus 1 over 1/9 minus 1 over 1/16. So 2 squared, 3 squared, 4 squared, plus dot dot dot. And there's only two things we need to show. First, we need to check if the nth term part of this is true. So if we take the limit as n goes to infinity of 1 over n squared, well, what do we know? Denominator gets to infinity. If the denominator is larger, the fraction goes to 0. So limit is equal to 0. The second thing we need to check is if the next term, 1 over n plus 1 squared, is that less than or equal to 1 over n squared for all n greater than 1. And because the numerators are constant, we can do that trick that we usually do. We know that n plus 1 squared, that's n squared plus 2n plus 1. Well, that's greater than n squared for all n positive, or all n greater than 1. Because 2n plus 1, we're just adding positive terms, so this is clearly true. That means if we flip it over, that's going to be less than 1 over n squared, since we are greater than 1 here. And yeah, we're done. Therefore, 1 over n plus 1 squared is less than or equal to 1 over n squared for all n greater than 1. And since we have shown the nth term part and we have shown it's decreasing, we can conclude that the series converges by the alternating series test. But I can go one step further. We know this looks very, very close to 1 plus 2 squared plus 1 over 3 squared plus 1 over 4 squared, which just happens to be your p series, where p is 2. Since we know that 1 over n squared converges, what we're saying is, we can show that if the absolute value is just the sum 1 over n squared, since this is convergent by the p-series test, we can say that the alternating series is not only convergent, it is absolutely convergent. Now, if the absolute value were to diverge, but the alternating series were to converge, it would be called conditionally convergent.